So, our topic for today is all about derivative function and logarithmic function. This is Baby Antungay Masulot and by Tilak Uto.
The derivative of exponential function f(x) equals to a over x, a is greater than 0 is the product of exponential function a over x, and natural log of a, that is f(x) equals to a over x in a. Mathematically, the derivative of exponential function is written as d open and close parenthesis a over x and dx equals to open and close parenthesis a over x over 1 equals to a over x in a. The derivative of exponential function can be derived using the first principle of differentiation using the formulas of limits. The graph of derivative of exponential function changes direction when a is greater than 1 and a is less than 1. Derivative of exponential function e over x. Now that we know the derivative of exponential function is given by f(x) equals to a over x in a. The derivative of exponential function e over x using the same formula is given by e over x in e equals to e over x because in e equals to 1. Hence, the derivative of exponential function e over x is the function itself. That is, if f(x) equals to e over x, then f(x) equals to e over x. Example number 1. Find the derivative of exponential function f(x) equals to 3 over x plus 3x squared. So the solution is using the formula for derivative of exponential function and other differentiation formulas. The derivative of f(x) equals to 3 over x plus 3x squared is given by f(x) equals to 3 over x in 3 plus 6x. So the answer here is the derivative of 3 over x plus 3x squared is 3 over x in 3 plus 6x.
Hello, good day. This is Baby Auntie Masulot and let us talk about the logarithmic function. So, what is logarithmic function? Logarithmic functions are the inverses of exponential functions. The inverse of the exponential function y equal a of x is x equal to a of y. The logarithmic function y equal log ax is defined to be equivalent to the exponential equation x equal to a of y multiply y equal log of a of x only under the following conditions: x equal to a of y, a greater than 0, and a is not equal to 1. It is called the logarithmic function with base a. Using our understanding of exponential functions, we can discuss their inverses, which are the logarithmic functions. These come in handy when we need to consider any phenomenon that varies over a wide range of values, such as in chemistry or decibels in sound level. The exponential function f of x equal to b of x is 1 to 1 with domain and range 0, and therefore it has inverse function called the logarithmic function with base b. For any b greater than 0, b is not equal to 1, the logarithmic function with base b denotes that log of b has domain 0 and range and satisfies log b of x equal to y if and only if b of y equals x. So for example, log of 2 of 8 equals 3. So since 2 exponent of 3 equals 8. So number 2, log of 10 of 100 1 all over 100 equals negative 2. So since 10 exponent negative 2 exponent equals 1 all over 10 of exponent of 2 equals 1 all over 100. So log of b equals 1 equals 0. So since b of 0 is it equal to 1 for any base of greater than 0. Furthermore, since y equal to log of b of x and y is it equal to b exponent x are inverse functions, log v of b exponent x equal to x and b exponent log of b equals to x equal to x. The most commonly used logarithmic function is the function log of e of x. Since this function uses natural e as its base, it is called the natural logarithm. Here we use the notation in of x or in of x to mean log of e x. For example, in of e equal log of e equals 1 of in of in. E exponent of 3 equals to log of e exponent 3 equals to 3 in 1 equals log of e of 1 equals to 0. Since the function f of x equal to e exponent x and g of x equal in of x are inverses of each other, in e exponent x equal x and e in of x equal x. And also, their graphs are symmetric about the line y equal x. Let us see this figure. In this graph, the function y equal e exponent x and y equal in of x are inverses of each other. So their graphs are symmetric about the line y equals x. So in general, for any base b greater than 0, and v is not equal to 1, the function g of x equal log of b of x is symmetric about the line y equal x with the function f of x equal to b exponent x. Using this fact and the graphs of the exponential functions, we graph functions log of b of x for several values of b greater than 1. So we graph functions log of v of x for several values of b greater than 1. So here is the graph. So in this figure, we see that the graphs of y equal log of b of x are depicted for b equals 2, e, and 10. So before solving some equations involving exponential and logarithmic functions, let's review the basic properties of logarithms. So here are the rule properties of logarithms. If a, b, c is greater than 0, b is not equal 1, and r is any real number, then log of b AC equals log B of A plus log of B and C. So this is what we call product property. So the number 2 is log of B A over C equals log of B of A negative log of B and C. So we will call it quotient property. So the last property of logarithm is log of B of A of R equals R log of B of A. So this is what we call the proper property, power property. So we have three properties: the product property, the quotient property, and also the power property. So let us solve each of the following equations for x. So let us solve 5 exponent x equals 2. So here is our solution. Let us apply the natural logarithmic function to both sides of the equation. We have in 5 of x negative in of 2. Using the power property of logarithms, x in 5 minus in 2. So therefore, we have x minus in 2 over in 5. So that's it. Thank you so much.